This is V. Sujit Babu from ECB section. Today my topic is about signal energy computation using residues. So let's quickly look onto the what are the contents. Introduction, theory for signal energy integrals, fundamentals of complex residues, applications to integrals with trigonometric functions, techniques for evaluating energy integrals, computation using complex analysis, formulation of integrals in terms of cos theta and sin theta. So let's look onto the residues method for closed contour integrals and example and problem solving approaches, and last and finally conclusion. So first we look on to the introduction. Signal energy integrals often involve expression of the form integral f of cos theta comma sin theta d theta d theta. Complex residues theory provides a powerful tool to evaluate their integrals efficiently by transforming trigonometric integrals in contour integrals the complex plane. This presentation explores how residues calculus streamlines are the computation of such integrals in signal processing. So let's look on to the another slide, which is theory for signal energy integrals. Complex residues are coefficient of the z minus z naught term in the function Laurent series expansion around 1 by 1 minus z naught term in a function Lorentz series expansion around singularity z naught. They allow evaluation of counter integrals around singular points using residues theorem and fundamental principle in complex analysis for integral computation. Application to integral with trigonometric functions, substituting z equal to e power I theta integrals involving cos theta and sin theta transform into complex contour integrals on unit circle residues theorem then enables direct calculation by summing residues inside the contour, simplifying the evaluation of signal energy integrals with trigonometric terms. Complex residues are coefficient of the 1 by z minus z naught term in a function Lorentz series expansion around a singularity z naught. They allow evaluation of contour integrals around singularity points using the residues theorem, a fundamental principle in complex analysis for integral computation. Application to integrals with trigonometric functions. By substituting z equal to e power I theta integrals involving cos theta and sin theta transform into complex contour integrals, the unit circle residues theorem then enables direct calculation by summing residues inside the contour, simplifying the Evaluation of signal energy integrals with trigonometric terms. Techniques for evaluating energy integrals. Evaluating signal energy integrals often involves transforming trigonometric integrals into complex counter integrals. Techniques include parameter substitution and converting cosine and sine terms using Euler's formula and employing the residue theorem. Precisely calculate integral values via the singularities within the contour. This method reduces complexity and improves analytical clarity in signal analysis. Computation. And now let's look on to the another slide, which is computation using complex analysis and formulation of integrals in terms of cos theta and sin theta. Signal energy integrals commonly appear as functions of cos theta and sin theta over an interval. By representing these trigonometric functions in exponential form, integrals can be expressed as contour integrals on the unit circle in the complex plane and setting the stage for efficient computation using complex analysis tools. Residues method evaluates integral by summing residues of singularities enclosed by a closed contour. This approach simplifies integrals involving periodic function by converting them into complex integrals along the unit circle, allowing exact evaluation through residue calculation at poles inside contour. Example problem and solving approaches. Example problems demonstrate how to apply substitute and residue calculation to solve signal energy integrals. Approaches includes identifying singularities, determining residues efficiently, and combining results to evaluate complex integrals, providing practical steps for tackling challenging integral expression in signal processing. The residue method evaluates integrals by summing residues of singularity enclosed by a closed contour. This approach simplifies integrals involving periodic function by converting them into complex integrals along the unit circle, allowing exact evaluation through residue calculation at poles inside the contour. Example problems demonstrate how to apply substitutions and residue calculation to solve signal energy integrals. So let's finally now look on to the conclusion. Complex residues theory offers a powerful framework for computing signal energy integrals involving trigonometric functions. By transforming these integrals into contour integrals and applying residue calculations become more straightforward and precise, enhancing analytical capabilities in signal processing and related fields. Thank you for your attention. Thank you.